Okay guys, welcome back to my channel. Now today we'll be discussing the last part of density and upthrust, which is upthrust. Now what is upthrust? Simple. Upthrust can be defined as the upward vertical force that acts against the weight of an object immersed in a liquid. I'll say it again. Upthrust can be defined as the upward vertical force that acts against the weight of an object immersed in a liquid. Now, this means whenever an object is immersed, either partially or completely in a liquid, there is always an upward force that the object will feel that is produced from that liquid against the weight of that object entering inside the liquid. Now, this is to say that whenever an object enters a liquid, there will be a reduction in the weight of that object in the liquid. Now, this reduction of the weight is because of the upthrust acting on it. So, in other words, we can say that upthrust can be defined as the apparent weight loss of an object in a liquid. Apparent weight loss, meaning there will be a difference in weight. The weight of the object on ground and the weight of the object in the liquid will have different values. What makes these values to be different is because of what now? Upthrust. Now, on the board, we see upthrust is equal to weight in air minus weight in liquid. Weight in air, the actual weight of the object. Weight in liquid, the weight the object feels inside the liquid. Now, this I say is equal to WR. Take note, WR refers to the resultant weight, which is that difference in the weight, and that is the upthrust. Because it is weight, therefore it is a force, and hence the units will be newtons. When we go further, weight, as we all know, is equal to mg. Mg, mass, times acceleration due to gravity. But now, the mass of this object inside the liquid is not the actual mass of the object. So we call it resultant mass. Resultant mass means also displaced mass. It is the mass displaced of the liquid caused by the object entering the liquid. Now, how do we find displaced mass or resultant mass? It is equal to the density of the liquid times the volume of the object immersed. I'm sure you recall that when we learned about density, we said density was equal to mass divided by volume. So if you make mass the subject of formula, you're going to get mass to be density times volume. So if we say resultant mass, because it is coming from the liquid, we will say the density of the liquid times the volume of the objects immersed in the liquid. So that gives us density of liquid, volume of objects immersed, and then G. Now, I wrote out density of liquid, that's density of liquid, volume of objects immersed, and then what now? Acceleration due to gravity. Okay, now, when we have an object immersed with a string or a rope into a liquid, an object attached to a rope, and this object is then lowered or immersed into a liquid, what happens in that system? Now, as soon as the object enters the liquid, either partially or completely, the object must feel the upthrust in that liquid. Now, on the board, we're going to assume that this object is not moving. It is at rest. Now let's identify the total forces acting on the liquid. I'll give you 3 seconds to identify that yourself. Okay, now the total forces acting on this object as it is here is 3. There are 3 forces acting on this object currently as shown on the board. Number 1, the tension in the string. Number 2, the weight of the object. And number 3, the upthrust in the liquid acting against the weight. Now, because this object is in equilibrium, and we know at equilibrium, summation of forces must be equal to 0. So that means upward forces must be equal to downward forces. Now let's check. How many forces are acting upward here? There are 2. Tension and upthrust. That is to say that the tension plus the upthrust must be equal to. Now, which force is acting downward? That is the weight. Must be equal to the weight. So, if we are asked to find either tension or upthrust, we can make either of them the subject of formula. Let's make tension the subject of formula here. So therefore, tension will become the weight of the object minus the upthrust on the object. Okay guys, now on the board we have an object is dropped into a liquid. An object is dropped into a liquid. Now, what will this object experience? Because it is dropped into a liquid, it therefore means that the object will be moving with an acceleration down the liquid. Remember, the weight of the object still acts downwards, and because the object is in a liquid, there must be upthrust acting against the weight that is upward. But now, because the object is moving, I am sure you remember that whenever objects are moving in opposite direction and they are in contact, there will be a frictional force produced to resist that motion. Now, same thing applies to liquid bodies. Because the object is moving down the liquid, there will be a frictional force produced by the liquid on the body of the object. This frictional force is called viscous force. Viscous force, also called viscosity. Because it is a frictional force, it means it must oppose your motion. Therefore, since the object is moving downward, viscous force will act upward. This object is not at equilibrium, it is moving. How do we bring out formula for objects that are moving for their total force? Remember, because it is moving, we then say the higher force minus the lower force must be equal to the resultant force. Take note, resultant force, according to Newton's second law of motion, is equal to ma, where m stands for mass and a stands for acceleration. Higher force minus lower force must be equal to resultant force, which is ma. Simple. We have an object at the middle. 2 forces act on this object, a force to the right and a force to the left. The force to the right has, let's say, 100 Newton, and the force to the left has, let's say, 80 Newton. Which of these directions do you think the object will move to? Answer the question in the comment section. Now, the object will move to the right. Why? Because the force acting towards the right is higher or greater in magnitude than the force acting towards the left. Now, which force actually made the object to move towards the right? If you know the answer, put that in the comment section. I will answer it now. The force that made the object to move is not the 100 Newton nor the 80 Newton. The actual moving force or force that made the object to move is the resultant of these two forces. How do we get the resultant? It becomes the higher force minus the lower force. That is 100 minus 80. That will give you 20. Therefore, whenever objects are acted upon by forces, to get the actual moving force, you just do the higher force minus the lower force, or the force in which the direction is acting minus the opposing force. In this diagram on the board, I'm sure you agree that since the object is moving down, it therefore means that the force going down is higher than the forces going up. Class, which force is going down? That is the weight. The weight is moving down, but the upthrust and the viscous force are moving way upwards. Therefore, it is safe to say that the weight minus the upthrust minus the viscous force must be equal to the resultant force, which is MA. Weight minus upthrust minus viscous force must be equal to MA. Now, this object will continue to move until the object attains what we call terminal velocity. Don't be frightened with the English. Terminal velocity basically means that it is the highest velocity that object will move with. And at that velocity, the object will not increase or change its velocity anymore. Therefore, meaning that terminal velocity is also saying constant velocity. Constant velocity. So when the object moves to an extent, it then attains constant velocity, which we call terminal velocity. Now, from Newton's law, when your velocity is constant, it is not changing. It therefore means that that object does not accelerate, because remember, acceleration is the change in velocity with respect to time. If this guy is changed in velocity and velocity is now not changing, therefore it means that change becomes zero. What is 0 divided by t? 0. Whenever velocity is constant, acceleration must be equal to 0. Therefore, at terminal velocity, also called constant velocity, the object will not accelerate anymore. So we can rewrite this formula as weight minus upthrust minus viscous force equal to 0, because 0 times m gives you 0. So this formula is applied when we have terminal velocity, while this is applied when the object is still moving, not at terminal velocity. Okay guys, now we've seen what upthrust is about. We can also relate relative density with upthrust. How? The relative density can also be equal to upthrust in liquid divided by upthrust in water. Now recall, upthrust is apparent weight loss. Therefore, The upthrust in liquid is the apparent weight loss in the liquid. Why? The upthrust in water is the apparent weight loss in water. So we have weight in air minus weight in liquid divided by weight in air minus weight in water. So this helps us to also find relative density apart from the previous formulas given. Okay, now let's talk about Archimedes principle. Now, Archimedes' principle, simply put, explains that when an object is immersed in a fluid or liquid, it will experience a buoyant force, which is equal to the weight of fluid displaced. That is too much grammar. Simply put, the volume of an object immersed in a liquid must always be equal to the volume of liquid displaced vertically upward. When you put an object into a cup or a bowl of water, you will always observe that the level of water in that cup or bowl will increase. Now, the amount at which that water increase, if you can measure the volume of that increase in water, it will be equal to the volume of the object you placed inside. Now, by writing the formula on the board, we can see that the volume of objects immersed must be equal to the volume of liquid displaced. I'm sure we know that liquids take the shape of the container they are in. So when we expect questions from our examination bodies from this part, you should try to remember the formulas for volume of some certain shapes. I will give you a few of them. We must know the volume of a cylinder, which is pi r squared h. We must know the volume of a sphere, which is 4 over 3 pi r cube. We must know the volume of a cone, which is 1 over 3 pi r squared h. These three volumes you should put in your memory because when asked to find volumes of liquid or objects immersed in water, we must use these parts when solving. Okay, now let's talk about flotation principle. Simple. Objects will float when the weight of the object is equal to the upthrust from the liquid. Therefore, whenever weight is equal to upthrust, the object will float. But if weight is greater than upthrust, the object will sink. Therefore, you will float if you can displace your own weight of the liquid. This helps people that swim to remain afloat in water by flapping their hands or their legs. They tend to displace their own weight or volume of the liquid. Therefore, floating simply says weight equals upthrust, then you float.